let's jump right in. And before we start writing some code, let's just talk a little bit about the Neo4j GraphQL library. So when we build a GraphQL API, there's sort of two processes that we go through. One is designing our type definitions and the schema for our API that defines what are the types, what fields do those types have, how are those types connected. That's the graph part in GraphQL, is how the types are connected. And then there's implementing what are called resolver functions. And resolver functions are the logic for our GraphQL API. How do we actually go to the data layer, fetch data from a database, write data to a database, whatever it is, these resolver functions have the logic for basically interacting with the data layer. And with database integrations like the Neo4j GraphQL library, it completely removes the need to write these resolver functions. So what you get for essentially free is the data fetching layer. So we still define our GraphQL type definitions, and that defines the GraphQL API. But then the Neo4j GraphQL library implements resolvers for us that generates data fetching code and adds a bunch of things to our GraphQL schema, like things for filtering, sorting, pagination, gives us ability to add rules for authorization, solves a bunch of problems that come up when we're building GraphQL APIs, like this N+1 query problem, which is a performance aspect. So really useful library. It's a JavaScript library for Node.js GraphQL implementations. The other thing that we'll be using, I said, is Neo4j Aura. So Aura is Neo4j's cloud service. There's different tiers here. We're going to use Neo4j Aura DB free, which allows us to spin up Neo4j instances in the cloud and start developing with them. So I'm going to go ahead and sign in to Neo4j Aura. Looks I'm already signed in. Great. And I don't have any databases, so let's create a database. I'm going to do Aura DB free. Let's call this Neo4j GraphQL, and I can choose what region. IO is fine. And then I have the option of loading an initial data set with movies data or a blank database to load our own data. We're going to do the blank database. Now it's going to give me a password, which I'm going to save somewhere, since we'll need that later on. There we go. And yes, I've saved my password. Let's continue. So dev.neo4j.com/neo4j-aura. I'll drop this link in the chat. This is the landing page for Aura. And again, it's free to sign up for Aura and spin up a database. So that's provisioning our database. Let's jump back to the GraphQL library page. And let's jump to the docs. So the Neo4j GraphQL library has a lot of different features. The basic idea is we write GraphQL type definitions, pass those off to the library. The library generates what's called an executable GraphQL schema. So basically enriching the type definitions that we specified originally with all the create, read, update, delete operations, with filtering, with pagination. There's even like aggregations that are added. And then implementing those resolvers, that is sort of the core data fetching logic for our API. So I'm going to jump down to this getting started section, and let's see if we can follow this to get up and running. So we're going to be creating a Node.js app. So you'll need Node and npm installed. Npm is just going to allow us to pull down some dependencies. So I've got an empty directory here Hopefully that is a good size. I'm going to do an npm init-y to just create a new node project and just use all the defaults. And then the next thing that I'm going to do, we'll create an index.js file. Zoom in one more level. That's good enough there. Okay. And now we're ready to install some dependencies. So we're going to install the Neo4j GraphQL library. We're going to install GraphQL, which is the JavaScript GraphQL implementation. And we're going to install Neo4j driver. So this is the Neo4j JavaScript driver. So what the Neo4j driver package is going to do is allow us to connect to Neo4j and send database queries. So we're going to create this driver instance, hand that off to the Neo4j GraphQL library, which is then going to handle our database connection. And then we have a few options here for the GraphQL server implementation. We'll use Apollo server. Apollo server is really quite nice. It allows us to basically just pass that schema object that the Neo4j GraphQL library is going to generate for us and handle network requests for our API. So we're going to install Neo4j/GraphQL, the GraphQL implementation. I'm going to install the latest 15 version. Version 16 came out a few days ago, and I haven't tested that yet. So let's pin to that, and we'll install Apollo server, if we can spell it right there. Okay, so while that's installing, let's go to index.js and start writing some code here. So the first thing we're going to do is pull in the Neo4j GraphQL class from the Neo4j GraphQL library. We'll pull in Apollo server and the GQL template tag. This template tag is nice. It just allows us to parse GraphQL strings in our code. And we'll need the Neo4j JavaScript driver. And then we need some GraphQL type definitions. So these type definitions, oops, not type, const type defs. The type definitions tell us everything about the data in our GraphQL API. I'm just going to leave some very simple type definitions, single type movie. That's kind of a placeholder. We will come in and fill this in later. These type definitions are very important, so we will revisit those. The next thing we need to do is create a driver instance. So we'll say Neo4j driver, and let's set some environment variables. So Neo4j URI is going to be our connection string to our Neo4j Aura instance, and database username is going to be Neo4j, but we will read the password out of environment variables. Let's format that. There we go. And let's set those now. So Neo4j URI is going to be, if I go back to the Aura console, that's going to be this string here. And Neo4j password, that's going to be the randomly generated password that I saved over here. Okay. Let's go back to our docs. Here's the docs. So we've got our driver instance. The next thing we need to do is create our schema. So we're going to instantiate the Neo4j GraphQL class, pass it our type defs, and pass it our Neo4j driver instance so it knows how to connect to our database. And then finally, we will just create a new Apollo server instance. And we're going to pass that executable GraphQL schema object to Apollo server. So grab the schema from our Neo4j GraphQL instance, and then we'll start Apollo server. And let's see, in the callback, we'll get the URL, which will be like localhost, something like that. Server ready at URL. Cool. And let's do a node index.js, give this a run. So it's ready at localhost 4000. Cool. So when we open localhost 4000, we get this Apollo Studio kind of landing page. And this basically will redirect to Apollo Studio, which is like a query workbench for GraphQL. So it's pointed at localhost 4000. So my GraphQL API that's running locally. And what Apollo Studio is doing, I think this is called the Explorer piece of Apollo Studio, but what it's doing is running what's called an introspection query against my GraphQL API that's running locally. So it's saying, hey, what are the types in the API? What data do you have? And then it does really nice things like generate documentation for us. So I can see all of the entry points for the API. I can see here are the mutation operations. I can see all the types available, which is quite simple. I just have movie, which just has a title. But that's quite nice. And I also get things like autocomplete in this tool to write GraphQL queries. So for example, I can query for movies and their title. And of course, I get back an empty array because, well, my database is empty. It has no movies in it. So that makes sense. One thing we can do, if we go back to our app, is set this debug environment variable. I think that's this in Neo4j GraphQL :*. So that will set the, I need to say Node.j, node index.js. There we go. So this is going to set this debug environment variable to Neo4j GraphQL : which is going to enable debug mode for the Neo4j GraphQL library. So now when I run a GraphQL request in Apollo Studio, there's a bunch of things that get logged to the console. So for example, it says incoming GraphQL request, here it is, no variables, JWT not configured. We haven't set up authorization. That's what that means. And then the Cypher query that was generated from this GraphQL request. So it shows us the database query that was generated from this GraphQL request that we didn't have to write. So notice when writing our code here, I said the common way to build a GraphQL API is to write your type definitions, then write your resolver functions that specify how to resolve those requests from the data layer. But we didn't have to write those resolvers. The Neo4j GraphQL library takes care of that for us, and here it's generating a database query, which is pretty neat. That's pretty powerful. Cool. So let's go back to our type definitions and revisit this. So in the book, in chapter 2, we start talking about this idea of graph thinking and thinking of your application data as a graph and going through this data modeling and API design process where we take our business requirements. And so the application that we build in the book is a business reviews application. So I can search for businesses. Businesses have categories. I can search for restaurants, restaurants near me. There's some location data in here. I have users who are writing reviews of these businesses in my API, and users want to sort of use those to find personalized recommendations. So based on my reviews for these businesses, what are businesses I might be interested in? Those are kind of the basic requirements for our GraphQL API. And so in the book, we go through the process of how do you translate that into a graph? How do you then translate that into GraphQL type definitions, and kind of what are the implications there? So we're going to go through that process. I like to use a diagramming tool called Arrows, which is just at arrows.app. I'll drop a link to that in the chat. So Arrows is a diagramming tool that allows us to create our graph models, but then also has lots of other neat functionality as well, which in this case is going to generate our GraphQL type definitions. So we said we're working with business reviews data. So let's create a business node. So this is our data model, and we can add labels to our nodes. So nodes, these are the entities in our graph. Relationships connect nodes. Nodes can have one or more labels, which is like a grouping of the node. So this is the business label that's going to identify businesses. And then we can add properties. So properties are the attributes, these arbitrary key value pairs that we store on nodes or relationships. So we might have business would have a name, it probably has an address. Business probably has an ID, like a unique identifier. And then businesses are going to be in a category. And a category is going to have a name. This is going to be like restaurant, bar, bookstore, that kind of thing. And we'll say that this business is in category. Now, a common question that comes up when you're going through these graph data modeling exercises are things like, should I model this as a node or as a relationship? In this case, we could model category as a property on the business node. We could also model it as its own node. And so I like to think, well, can I uncover some useful information by traversing through this thing if I modeled it as a node that I couldn't if it was modeled as just a property on the business node? And category is a really good example here because let's say I'm going to have other businesses that are connected to the same category. So maybe this is going to be like all of the coffee shops. And this is going to be in category. Category, there we go. And so now if I'm thinking of like, how do I find similar businesses? Well, I can traverse from this business to its category to other businesses connected to the same category. And so that's useful information. That's something that I couldn't really do by traversing the graph if I was storing category as a property on the business node. We're also going to have reviews. So a review is going to have an ID, like a unique identifier for the review. It's going to have maybe the date that it was created. And maybe each review is going to have some text. I'm going to say like, this was a horrible restaurant, never come here again. Stars, I'll give it 1 star, never come again. And so let's see, the review is going to be connected to the business. We'll say the review reviews the business. So we'll reverse that. Let's get this extra node out of the way for the business. And then a review is going to be written by a user. So we're going to have users. User is going to have a, I don't know, maybe like a screen name. And we'll say the review is written by the user. So we've got categories, businesses, reviews, users. And so the next thing we have to do is think of, well, okay, so we have an initial data model, but can I answer the questions that I have? Can I think of a traversal through the graph that is going to address the business requirements of my application? And this is where tools like arrows come in really handy, because I think the graph modeling process is really an iterative process. We don't sort of look at our business requirements and then immediately sketch out what our database schema is going to be and into the day. It's this iterative process where we look at this graph, we look at our business requirements. So you can grab those from, I think, the beginning of chapter 2. Yeah, here we go. So as a user, I want to search for a list of businesses by category, location, and name. Well, I say, okay, can I search for businesses by category? Well, sure. I just search for these category nodes, and I traverse to the business, and I can show whatever businesses are connected to the category that the user selected. That works. And I work through my business requirements and say, hey, is there a traversal in the graph that answers this question? Yes. If we go through all those, and we say, yes, we can traverse this graph to answer all of our business requirements, then yeah, we're done. And we can move on to the next step, which in this case is going to be translating our graph model into GraphQL type definitions. We talk about how to do this in the book, sort of manually, what is the syntax for GraphQL type definitions. But one thing that's nice about arrows is I can kind of cheat. If I go to export and then to GraphQL, I have my GraphQL type definitions here that have been generated from that diagram that we just created. So I'm going to copy those. And in the code here, I'm going to paste those type definitions to replace kind of the very basic placeholder that we had. Okay, and this is kind of a starting point.